So students always ask me, which value of R do I use for this problem? And I say there seem to be many, many, many different choices. And the answer is there's really only one value for the ideal gas constant, but it has lots of different units. It is a universal constant. It's pressure times volume divided by the numbers of moles times temperature. So the value for R that you get is going to depend on what units you have for pressure, what units you have for volume, what units you have for moles, and what units you have for temperature. Almost universally in chemistry, we stick to the same value for units of moles. And we've agreed on what the definition of Avogadro's number is, and a mole is the number of particles that are in 12 grams of carbon. For temperature, we're always going to use absolute temperature, and we're going to stick with units of Kelvin. But no one can decide what the units for pressure should be or the units of volume should be. And so as a result, for pressures, we have atmospheres, we have bars, we have torr, we have millimeter of mercury, we have pounds per square inch, we have other crazy ones that we can dream up. Volume, almost always in liters, but it could be in cubic decimeters, could be in cubic meters, cubic centimeters, could also be in gallons or bushels or other absurd units. And so depending upon what choice of units you have in the problem, you're going to have to pick the correct units for R. So for example, if you had pressure in atmospheres and volumes in liters, it'd be 0.8206 liter atmospheres per mole per Kelvin. But if you had pressure of bars, it's 0.08314 liter bars per Kelvin mole. Or alternatively, maybe you have Pascal cubic meters, then it's 8.314. And so the answer to which is the correct one, it's the one that makes the units work for the pressure and the volume that you're working with.